Here's a good question that you may come across for equilibrium. We're dealing with KSP, so we're talking about dissolving a solid and working with the equilibrium with the solid versus the aqueous ions. We also have a common ion because we have silver chloride and hydrogen chloride as the acid in solution. So we have a common ion. Right? But as equilibrium problem, you should always start first with the equilibrium, with the reaction equation, and then get your equilibrium expression to work out what the constant is. So in this case, we have silver chloride, and as I said, because it's a KSP, our equilibrium is we're starting with solid and we're dissolving it to get the aqueous ions. We've got silver ions. We also get chloride ions. These are aqueous, of course. Now, if it wasn't in HCl, if it were just what's the solubility, usually in water, unless you specified something else, then it would be a really straightforward problem because the KSP is simply equal to the concentration of these ions multiplied together. Of course, raised to the power of the amount of moles, but in this case it's just 1. For your standard equilibrium expression, it would of course be over the concentration of the reactants, so we have our AgCl, but of course because it's a solid, we don't include solids in equilibrium expression. So in terms of KSP, that's all we have. Now, like I say, if it were just the solubility in water, we wouldn't have to worry anything about the HCl, it would just be a straight up multiplication. Now we've got this number, the KSP is given to us as 1.8 by 10 to the minus 10. So the concentrations of these two are equal because of the molar ratio. So you're getting one of these for every one of that. So the concentration is equal. You could write either one and just square it. So now we just need to take the square root of this, and it gives us the concentration of the chloride, which is also equal to the concentration of the silver. So you can square root that, which gets rid of this, and we now have the concentration of the chloride ion as equal to 1.34 by 10 to the minus 5. Now this is the same as the concentration of the silver ions. And because of the mole ratio, 1 to 1 to 1, that's actually the same as the concentration of the silver chloride. Now the questions are not asking for concentration, it's asking for solubility, but they're the same thing. Because we're talking about a solid dissolving, we're talking about getting a saturated solution. So at equilibrium, the solution is saturated. If it were unsaturated, we simply haven't reached equilibrium yet because more of the solid would dissolve. We're not dealing with supersaturated solutions, so we're not worrying about it going too far to the right. So by working out the concentration of the chloride, or the concentration of the silver, we've actually found the concentration of the silver chloride, which is the solubility of the silver chloride, because that equilibrium concentration is the solubility. But you're not going to get a question this straightforward. Right? That was just the solubility in water. But of course we do have the common ion. We've got chloride from the silver chloride. We've also got chloride ions from the HCl. So it's not going to be this straightforward. So we need to know what the concentrations are. Okay, because from our KSP, it's concentration of silver ions times the concentration of the chloride ions. But what actually are the concentrations? We're not told, so we're going to just let X amount dissolve. Okay, we're going to just use X and then we'll solve for X. So we can start by saying, well, okay, if X mole dissolves, then our concentrations will become, we've got X mole of silver ions and X mole of chloride ions. So our concentration of silver is X mole, concentration of chloride is X mole. Now this is just from your silver chloride, okay? But of course we've got that as well. So we're getting more chloride ions. Now it's actually X plus whatever we're getting from the acid. And because our acid is HCl, this is a very strong acid, it completely dissociates. So you can say that the concentration of the acid is equal to the concentration of the chloride ions. Because it's a monoprotic acid, we get, if we've got 0.1 molar solution of HCl, we also get 0.1 molar hydrogen ions and 0.1 molar chloride ions. So we've got X mole of the solid dissolving, but we're also getting another 0.1 mole per liter of the chloride ions from the acid. Okay? So now, of course, the maths becomes just a little bit more tricky. So now when we have our equation for KSP, we've got silver ion concentration multiplied by the chloride ion concentration. And silver is no common ion anywhere, so if X mole dissolved concentration is X mole per liter, assuming this is in a 1 liter container. So we just have now X, but then now, of course, chloride ion concentration is X plus 0.1. So, and of course we've got our number for KSP. So just clear up some board space. If we expand this out, we'll get x squared plus 0.1x. Now, this is equal to what the question gave us, 1.8 by 10 to the minus 10. So we could put that number in, 1.8 by 10 to the minus 10. And then we notice we've got an x squared, and it says number of x and a number, and we can take this number across the other side. It won't be here anymore. So there'll be nothing there. And of course we do the opposite when we take it across the equal, so it's now minus 1.8 by 10 to the minus 10. This is your quadratic equation, and you've got a formula for solving your quadratic equation. So we'll do it that way first, and then we'll do it another way, which is really quite a bit easier. So if we look at these numbers, the number in front of the x's, you've got your A, you've got your B, and this whole number is your C. Then we have the quadratic equation. When you're solving for x, which is really what we need to do, because we said let x mole dissolve, well, we need to know how much actually did dissolve, so we're actually needing to solve for x. Well, x is equal to minus b plus or minus square root of b squared minus 4ac, and that is all over 2a. So we did numbers for a, b, and c. A is of course 1, it's like algebra, you don't put it, but it's a 1. You plug your numbers into this, and you will of course get two answers, because it's minus b plus or minus the square root of all this. So you're actually going to get two answers for this. But let's plug in those numbers. We've got, what do we have? Minus b is 0.1, plus or minus, we've got 0.1 squared, minus 4 by, well, a is just 1, so 4 by 1, by c, which is minus, needs to be longer, 1.8 by 10 to the minus 10. This is, of course, all over 2 times a, which is, it's just going to be 2. Okay? So you plug your numbers in to solve for x, and then you reach for your calculators, and you actually do said math. But like I say, you have to do it twice, because we actually have to do it with your minus 0.1 plus all of this, and then all over 2, and then your minus 0.1 minus all of this, and then all over 2. And you'll get two values for x. So x will now be either minus 0.1, or it will be x equals 1.8 by 10 to the minus 9. So you get two answers for x. One of them will make sense, one of them will just be ridiculous. Now, if you think about what they actually mean, we've said, we let x mole dissolve. Well, if we've got minus 0.1 mole dissolving, that says it's actually, less than none is dissolving. It means we must be actually forming the solid. Well, the whole point is that we're dissolving this, okay? We want the solubility to make our saturated solution. We need to dissolve it. So if this were the right answer, we would actually be going this way. We're dissolving less than 0, so we must actually be forming. So that one is just a silly answer. Can't use that. So it must be this one. X equals, admittedly, a very small number, so not much is dissolving, but some of it actually is dissolving. So now we have the value for x. Now earlier we said that the concentration, because the mole ratio 1 to 1 to 1, concentration of chloride ions is equal to the concentration of silver, which is equal to the concentration of the silver chloride. So you've solved for x, you're basically done, but you actually need to specify that this is the answer. You can't just say, well, x equals that. That's lovely. The question didn't ask about x, the question asked about the solubility. So you need to actually do one more, just a statement. You actually have to say that the solubility of your silver chloride in your 0.1 molar HCl is equal to the concentration of the silver chloride, which is equal to the concentration of your silver ions. And remember we said let x mole dissolve, so we're finding concentration of that, which is equal to the concentration of that, which is your solubility, which is the question asked about, and we just found it. It's 1.8 by 10 to the minus 9 molar. So this is your final answer here. The solubility of silver chloride in 0.1 molar HCl solution is 1.8 by 10 to the minus 9 molar. So whilst we've got the number here, you should always state what that number actually means. The question didn't ask what is x, the question asked what is the solubility. So yes, you solve for x, but you need to state that, well, that is the solubility. Okay, so there's your final answer. There is, of course, a much easier way to do it. You get exactly the same answer. Because quadratic equations are okay, we've got our quadratic formula, we can work with that. But sometimes you'll get problems instead of x squared, there'll be x to the 3 or x to the 4, maybe x to the 17. And the maths with all these things becomes exceedingly tricky. So quadratics, they're alright. When it steps up a bit more than quadratic, then you can get into a little bit of trouble. What we're going to do now is make an assumption. And we can do this because this number is exceedingly small, by 10 to the minus 10. That is a tiny amount, right? Now this is how much is actually dissolved, right? We want to find out how much dissolves. Very, very little amount will dissolve because this is so tiny. Because so little of it has actually dissolved, then we can basically ignore the chloride from the silver chloride because so little of it dissolves. Obviously some did, we need to find out how much. This is the concentration of the chloride from the silver chloride is so small compared to the concentration from the acid solution. Remember we said because this is a monoprotein, it splits up, you've got 0.1 molar hydrogen ions and 0.1 molar chloride ions. 0.1 molar compared to the tiny, tiny amount you'll get from the actual solid dissolving. So we're going to now ignore the chlorides from the solid. Okay? You have to say this. You must always state your assumptions. We're going to assume that the concentration of the chloride is equal to 0.1 molar. Alright? And this is just from the acid. You don't have to say it's from the acid. You don't have to explain your assumptions. Okay, so you don't have to write this, but you do have to write your assumptions. Because, is the concentration actually 0.1? No, it isn't. It's a little bit more. It's 0.1 from the acid plus a little bit more from whatever does dissolve. But that little bit more is so tiny that we can ignore it. It's tiny compared with the amount we get from here. This makes the equation so much easier because now, of course, we've got our equilibrium expression, KSP, is the silver ion concentration by the chloride ion concentration. Well, we've got a number for KSP. The question gave us that. 1.8 by 10 to the minus 10. And we now have a number for the chloride ions. Before we didn't, we had two unknowns, which is why we had to say, let x mole dissolve and then we'll go and solve for x. But now we've actually got a number for it. So we can put that number in. Now we only have one unknown, which is brilliant. We take this, cross the equals, do the opposite. It's now divided. And we solve for the concentration of the silver ions. When we divide by 0.1, we're just going to change that indice by 1. That will become a 9. And there's our answer, right? So our concentration of the silver ions is 1.8 by 10 to the minus 9. Exactly the same number we got before by doing the very long version through the quadratic formula, etc. And then, of course, you'd need to again state that the solubility of your silver chloride is equal to the concentration of your silver chloride, which is equal to the concentration of your silver ions, which we've just found out is 1.8 by 10 to the minus 9 molar. So again, you don't just get the number, you need to say, because the question asks what is the solubility, you have to say the solubility is this. Okay? And how do we go from solubility straight to a number? Well, the solubility, because it's a saturated solution, is equal to the concentration. And because in this case it's a 1-to-1 ratio, well, that's also equal to the concentration of the silver ions, which we found. So there's our final answer, and then we are happy.
Hey you, hit the like button. Yeah, and the subscribe one too. Yay!